Okay, good evening everyone. So today we'll be trying to solve this question called Pascal's triangle. Given an integer number of rows, return the first number of rows in the Pascal's triangle. Question is pretty straightforward, and number of rows can be maximum of 30. I think there's something called as Pascal series as well. Let me just say Pascal series. Okay, Pascal's triangle is a very classical concept then. One, 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 two, three. Okay. I mistakenly looked at the formula. Let's like okay. Obviously, we will be able to solve using the formula, but like assuming that it's a new question, let's see how we can solve it. Let's take things to paper pen. 1 second. Yeah. Okay. So we have a triangle, not a triangle, I mean a pyramid structure. So let's talk in terms of ABC. So I know that this will always be 1, right? uh, so when I start my, let's say I have to make a triangle of 5 loops, let's say 4. We are giving a num rows as 4, right? So in that case, obviously my first if I loop it, then it will, the first number will always be 1. I'll make the entry, then I will take 1. It seems like a recursion question, to be honest. Okay, let's see. I take 1, so I take this number, I sum it with the next element, but there is no next element, so I put it here 1. Then like in a classical sense, we always take from the above, so again we will do the same 1. Then once I complete 2 elements, so I know that the number of elements will be equal to the rows. Number of elements be equal to the rows row, right? So row plus 1, if our row is starting from 0, so like this will be 1, then 2, uh, 3, 4 again. Okay, so that's pretty clear. Now now the question starts. We will, what we'll do is, we'll, as soon as the row completes, that is number of elements is equal to the row plus 1, assuming row starts from 0, so we will move to the next one. So in the next I will again put up a 1. Why would I put a 1? Because like that's the norm of the first and the last element. So first and last element in a row will always be equal to 1. Alright, yeah, will always be equal to 1. So I come here, I can place a check like this, so I'm just identifying the checks we can do. Then first and this done, that's, we know that it will get placed. Then all the, like we come here, we know that only one place is empty, so like we come here, we take the like 2 at a time, we have to take 2 at a time, and 2 at a time can be overlapping, so we take these two, so these two will become 2. then our elements will complete. I will come here, I will put 1, then I will check the like previous one, so I will take these two, 1 2, that becomes 3, then I will take these two, 2 1, that becomes 3, right, and this then is 1. Yeah, right, then I put 1, I again take the previous in the pair of 2, so previous row elements need to be taken in a pair of 2, need to be taken in pair of 2. Okay, so I think I have a rough idea of the question what we need to do. So let's like try to form an algorithm here. And till when are we expecting to like go? Like we can simply say, obviously we will have to use 2 for loops, because one is for this, then one is for each row. So for outer for loop, I will just say loop. So let me give a heading to it, algo. So I will loop from, like our row starts from 0 to num rows given in the like question, num rows. Oh sorry, I forgot to show you the signature, function signature. Let me just quickly change that. So yeah, this is the function signature. We are giving the inputs in integer, and we have to give the output in the list format, like a list of list. Okay, let's get back to the question again. Okay, so loop from 0 to num rows. Then what we will do, we'll just say if number of elements equal to row plus 1. So for each row we have to take the elements, right? So I have to actually keep track of the row. Yeah, so from 0 to 1, if I just replace it with for loop, then I would be the variable for that. And again I would say for like for each row for I, right? So we are saying that for each row will be the equal element. So if I start from 0, then I should go to I. So for, or maybe let's like we are writing the algo, not that. So we can say loop from 0 to I, right? Now 0 to I, if I loop, I will just say that I will put in like if and let's take j, right? So j would be my j equal to 0. I will insert where I have to take a row as well, right? So one will have one I will have my result list, and one I will have my row list. Okay, 1 second. So we will have a, like, this is my result list and one will be my row list. So if j equal to 0, I'll just say row list dot add 1, right? Similarly, if j is equal to, like, we are looping from 0 to I, I am looping, so obviously we will say if j equal to I minus 1, that is the last element, then I will just add a row list dot add 1, right? That makes sense. So yeah, that makes sense. So if I, so we have started the loop here, then what we have done is we took the loop, and we inserted the those starting.
But first you need to unlock your device.
Yeah, so first we need to insert at the middle as well. So what will we do here? That's the crucial question, right? What will we do in here? So see, uh, in this we have to take we have to keep track of the last list as well, right? Because I'm basically summing from the last list only. So okay, makes sense. Let's take a current list and a last list. So we'll take a current list and we will initialize a last list as well, right? So simply, if my last list does not exist, right, if my last list does not exist, I'll put on 1 and I will continue, right? Because it doesn't make sense to do any operation in that case. So if my, if last list equal to null, will it be null? Okay, we will initialize it. So last list dot is empty. Just say, so if last list is empty, let's say last list dot add 1, right? And continue. So we will again come here. Now the last list is not empty, so we will come here, and since I have inserted this element, I'll start from 1, right? Because loop from 0 to, that will automatically happen. Okay, so just check 0 to this. So first one is 0, or do one thing now. What? Do one thing. Take this. Let's like take the last list. One second. will just like we will insert the last list here only. Dot add one, so it will always contain one, right? Then I will just need the current list, and we can start the loop from 1. Yeah, makes sense now. So we'll start the loop from 1 now. How much time have we spent till now? It's around 15 minutes we have spent. Okay, no problem. So loop from 1 to the numbers. Now current list, I don't have to do that handling anymore. So if current list, we will initialize the current list. I will say if j equal to 0 or j equal, we will add this right in the mid. What I will do, so I think 2 is a special case here. I will, what I will do, I will take the last list. Let me just check. So what we will do is basically we will take the last list in the pair of 2 if I can form it. If I cannot, I will skip. Okay, so I will just say if last list dot size is greater than 1, then only I will do this operation, right? Then only it makes sense because we need a pair. Okay, so I'm just zooming in a bit. So if last list size is greater than 1, then what we will do, we'll take the 2. So again I okay, so it will run in the for loop. It's in a for loop, right? Okay, so if last list dot size is greater than 1, I actually have to keep a pointer as well, right? Because, or I can I remove those elements? No, at each addition I can because last list will in any case will be inserted into a result list. So like I can, if it's 0, given 0 we have to print at least 1, right? Numbers is 1. Okay, it's 0, we don't have to print anything. So, okay, so is it make sense to add a last list dotted here? Because then last list, okay, for 0 we can basically I think handle that case. So 1 second. Upsi dupsi क्या हुआ? Okay, 1 second. Okay, so if we can just handle if like num rows equal to 0, return 0. Num rows equal to 0, return empty list. ठीक है. So now like we have handled the 0 case, then current list 0 to 1. If last size is greater than 1, what I can do is I can basically modify the last list, right? I can, because I don't, it's just for tracking purposes. So I'll just say last list of I. No, last list 0 would not make sense, right? If I'm removing the element, can I remove the element from start? Doesn't make it will also increase the complexity if we remove the element from start. So let me just think. So what I'm planning to do, it will be a reverse list. So will it make sense? So if I reverse that 1 3 3, if I reverse this, oh, it's always going to be the same. Damn. So in Pascal's triangle, each list we can say would be a palindrome. So it doesn't matter that if I remove the last or the first, right? Because it will eventually add up. Makes sense. So what I will do, I will just take the end last two elements, and then I will remove one element from the list, right? So if I do like this, so I take 1 3, that becomes 4, I remove 1, then I take 3 3, that becomes 6, then I remove 3. Okay, that makes sense. So what I will do, but how will I yeah, I can. How many? Okay, I will say sorry, I will say last list, last, so ele1, that's basically my last list, dot length minus 1, because it starts from 0, right? This would be element 1, element 2 would be same, except that would be last list minus 2. And what I will do, I will add this to the current list dot add the element 1 plus element 2, element 1 plus element 2. Then what I can do, I will just say last list dot remove. Okay, so I have added that element 1 and element 2, and then I removed that element from here. Each time will the actual length of the list will reduce. So that's where the difference between size and length comes in, right? So okay, so length will be the actual length, and size would be the allocated size. That I think. Okay, we'll see in code. So once that is done, I think this will make my list complete. And then before like closing the list, just check. So we'll say current list dot add 1, right? Okay, so what I can do when I will be out of the loop, out of this loop, right? Then I will say now my last list will be the, or we can first add, so it becomes a logical operation. We will just say result list dot add the current list, right? And then our last list will be equal to the current list. So that completes my code, I think. Let's dry run this on this standard example. Let's take n let's take 6, n equal to 6. Let's dry run for this. Okay, so uh, my res list is there, last list dot add. Okay, so we will start the loop from 1, because obviously we will starting from 1 to the 6. So first would be 1, and in case of 1, that is my row number 2, we will be traversing from 0 to 1, right? So for 0 I will come here and I will say okay, it's 0, put 1, right? Then should I continue? Like, okay, yeah. Like if I okay, I can add. Why can't I add? I can add, but then one. Okay, I think I have to add continue everywhere. Right, so I can just say continue here, because once the element is inserted, count. Similar for this, like it will be count. Right, I will, once I add an element to the list, or maybe I can figure out what to add first, right? Then I can, basically I don't have to continue there. I will just figure out what to add. Anyways, both approaches work. So I have added this and then I will continue. So I am at 1 now, right? So I will just say last list dot size. No, it's not, because last list contains this. So I will come here and I will say yeah, 0 1, and that makes sense. So this will also put 1. Let me just check. Why will it put 1? My j, that j I'm running was 0, so I put this. I said continue. My j became 1. Okay, my I is 1. Is my I 1? Yeah, my I is 1. So why would I do this? Right, I will just say if j equal to y, because starting from 1, right? If it would have been starting from 0, then it would have been it. Okay, so if j equal to y, that is 1 equal to 1, I will add 1. That's simple. Now let's take it a little short, because this should become a pyramid structure. Okay, so okay, what's the time? How much time have we taken? Almost 30 minutes. Okay, we okay, 30 minutes approach, 15 minutes coding, 45 minutes I allocate for this, assuming this is a medium question, but I don't know if it's a medium easy question. Okay, I'm just taking it to be a medium. I hope it is medium. Okay, so now if I start from 1, after that my row become 2, and again I come here, I will say 0, that put 1, I will say continue, then up to I, right? So my row is 2, 0 1 2, but 2 contains true element. What the hell? 0 contains 1 2 3 4. Okay, I'm starting from 1, my bad. 1 then becomes 2. Okay, that was 2, now it's 3. Perfect. So 3, so I became here 0 1, then I put 1, Now one my last list dot size. Have I updated my okay, the last list also got updated. So last list man, now this list. So last list dot size is greater than 1. Yes, it is. Also element last list, take this element, add it and put into the current list. So I'll put it into the current list, right? And now I will say okay, just I will track a last list as well. Okay, so now I'll say okay, let's remove this. I have removed it, right? Now I would say continue. Continue. J equal to 0. Nopes. If class data size is greater than 1, no, it's not. I would say not size, I would say length. Again, small distinction, but yeah, length is greater than 1. No, it's not. Then I will come here. I'll say j equal to I. Yeah, it is. So that puts a 1. Right. Now I will go to 1, 2, 3, 4. So in 4 I will come here. I will say 0 to I, and so again I will put 1. Then I will, my last list is 1 to 1, 1 to 1, right? So I will take the last element in the next iteration, obviously. I will take these two. I will say there would be 3. I will remove this. Okay. Then I will again come here because it would be continue. Then I would take these two. There would be 3. I will remove 1. Is it 1? No, it is not. Okay, I think it is like working. The solution is working good. Let's just 1, 2, 3, 4. Let's do for a 5. We are not going to 6. Just assume it to be a 5. Okay, so now for 5, obviously this will run. So again, that would 1 second. Yeah. Okay, so for 5, we will come here. We will take 1. Then my last list will contain 1 3 3 1 1 3 3 1. I'll take these two 3 1 4. Then again I will continue. Obviously I will remove this, and then 3 will take 3 3, that would become 6, right? It is 6. I hope it is 6. 3 4, yeah. Okay, so we'll remove this again. Then I will take 3 1 4. I'll say continue, and did I remove that? हटा दिया था 4. Yeah, I think 1 second. Okay, so I take 3 3 this, I take 3 this. Yeah, I think this is working. Like this is a working solution, and we like assuming it's a right solution, we took around 33 minutes to come up with this. So okay, let's come back to the board and let's easily code this up. I hope that everything works. I'll just say Jai Mata Di. Just kidding. So I would say first of all, let's take the variable. So we'll have a list of integer. Just copy this as only. Let's try to code this up fast, okay, without mistakes, obviously. So this will be my result list. What's that? Okay. New of array. Okay, weird flex. ठीक है. Okay. Now I will just place a condition if num rows equal to 0. return this empty list from here. Return res list empty. Okay, so now I will take a list of integer that would be my last list. New array list. Last list dot add. Right. Okay. Now I will just say for int I equal to 1 is less than equal to numbers minus 1 I plus plus. Okay, now I will initialize my current list of integer. Current list array list. Okay, now I'll take a for loop. J equal to 0. J is less than equal to plus if j equal to 0, current list dot add 1, and also continue this list. If let's check array list dot length list dot ngth. My bad. Oh, okay. It has a size method and size capacity. Okay. Okay. My bad. Size is greater than 1. Then only I will do this. Current list or maybe current list. Current list dot. No, my bad. Just say int element 1 which is equal to last list dot size plus 1 should because it's zero based. Okay, similarly for element 2 plus 2 dot add element 1 plus element 2. Say continue. Okay, my bad. It's removed from the list as well. Last list dot remove. Continue. If last list size. Why last list? If where is j na? If j equal to I, say current list or okay, I'm again here. It's current list. Current list dot add 1. Put 1 there. Right, I'll just say continue, and if it continues it will fall off the loop. Right, Once all that is done, my current list is inside this loop, right? Well, okay, if that's all done, I'll just say just list dot add current list, and my last list will become my current list, right? Yeah, yeah, this should work. Let's just run the code. Obviously, it's a compile error. Doesn't array is required. Oh, my bad. Oh, dot get. Okay, remove method must last list dot remove list dot arrays dot remove exists, right? Or am I missing something? Except the indexer to be removed, except the object to be removed. Am I increasing my complexity due to this? It's already like 2 loops, so n square we are already doing, right? It can go up to n rows, then it will also so it's obviously n square. Okay, just provided it. Okay, run. List. Wow. Hmm. Hmm. So what I have noticed is I become one, this one, this one, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, first of all, okay, so we are starting from 0. 1 second. Okay, so okay, answer is coming out to be right. It's only that my current list is getting messed up somehow. How much time have we spent? Almost 44, like was expected to. So it's almost solved, but I think current list would have been somewhere manipulating. It's weird. So is this current list? Current list dot one. I'll say continue. Say Not j is not 0. Obviously in second element 1, element 2. Add both the elements. So we must just remove the last element. Continue should work, right? Hmm. Code seems correct. I mean, this code, like I have reviewed everything. Oh, I see. Okay, so what this is doing is it is referencing. My bad. We have to actually create a new list because it will pass by reference, and yeah, now it should work. Yeah, it's working, right? For 0 also it's working. Oh, it never had a 0 case. My bad. Anyways, so up to 30 it's working, right? Then it's not giving any TLE or something. Yeah, it's like working fine, I would say. Just check out the last element. Looks good to me. Let's submit this. Okay, it is accepted. Great. So it's n square. Uh, let's read on Pascal triangle a bit. Pascal triangle. The entry in the nth row is denoted nk. For example, history the pattern. Maybe it's a binomial expression. So I'm saying that if I the sum of the elements of single row is the sum of the interesting. Interesting, interesting. Let's look at the official solution. And I hope it was a medium. Ah, this one was easy. Anyways, took around 45 minutes to solve it. Anyway, okay. My bad. TP. Interesting. Not just you, buddy. Not just you. One approach, one approach. So if you have the row of we can easily move to the next row by the pair of adjacent values. It's very simple. That row is constructing because we construct each row based on the previous row. First we generate the overall triangle list, which will store each row as a sublist. Then we get Then we check for the special user as we would otherwise return 1. Since now is always linear, we can initialize triangle with 1. So this to fill as follows. Okay, I'm yet to study the DP. Base case first row is always 1, triangle dot add, but like I said that it would like have some recursive solution, and when we do recursion with memoization, that is DP, right? One second. Is recursion with memoization DP? Recursion with right, so recursion with memoization is my dynamic programming. Are we sure this is towards recursion with memoization is DP. Okay, so basically it was a recursive solution. We just found a way to memoize it. So base case first row is always 1, triangle dot add new, triangle dot if row equal to 1, row num is less than num row plus plus. He also took 2 rows, row and previous row, and this is a triangle, so it makes sense. Okay. We never had to check for that. Anyways, did I just did DP? Is this solution DP? No, no, no. Is it? Because we did the exact same thing. How is this a DP? Sorry. Hmm? But we did the same solution, I guess. He took a triangle. I took this. I handled this one not needed. Later, no. I did in n square. He also did it here. So what is he doing? I am doing it inside the row. How does it matter? So first row is always 1, 0. Oh, this can be simplified a lot. A lot it could be simplified. Right, because it makes sense. Let me just modify the solution a bit. plus dot add one, dot add one, remove this, remove this, no need to remove this. Let's make it shorter a bit. Is it also removing? But it is not removing from the previous row, right? Each triangle other than the first and last of each row is equal to the sum of the elements above and to the left, above and to the right. So it never added a condition for us. J is equal to 1, j is less than row num j plus plus. It just started from 1. So it never have to check that j equal to 1, j is less than. So row num and I are exactly same. So that is okay. So that automatically I think solves this issue. Great. Let's try for 5 I think. Oh, my bad. Yeah, so okay, this could have been a lot simpler. We never had this case in the first place, so I just have to check. Okay, what about my last solutions, man? It took only one? That's okay, what? It. Anyways, I think, yeah, this one is the one that I stumbled almost 10 minutes ago. Okay. Interesting. Okay, it was an interesting problem. Like, you can say this was my introduction to DP. What is that? This was my introduction to DP. So we are keeping track of the last row, and we are like computing basis that was DP, but I always thought a DP as a recursive Okay, I will give it a read, but yeah, this is a solution that works pretty neat, would say, and we took around 45 minutes to solve it, which is a lot of time. For a easy, I am currently targeting around 30 minutes. Okay, and I think tomorrow's video would be like I won't have my laptop with me, so I guess I will upload that separately by separately shooting, because I have to go somewhere. But yeah, I will continue with the consistency. So yeah, that's it.